Ever jump into your car on a freezing morning, turn the key, and hear nothing but a sputter? A mechanic starts with the battery cables. On a computer, you verify the physical power cords first. Once the electricity is flowing, you check the internal startup settings, called the BIOS, to confirm the computer actually knows where its files are stored. If the power is flowing, the next culprit is often the starter motor. In Linux, your starter motor is a small program called GRUB. Its only job is to get the main operating system spinning. If that starter program breaks, your system goes nowhere. By plugging in a USB drive with a temporary Linux system, often called a live CD, you can jumpstart the machine. As this document shows, to fix GRUB, you boot a live CD to reinstall it. If the system freezes with a kernel panic to protect data, you enter recovery mode and check error logs to disable faulty drivers. That frozen startup screen represents a deliberate pause. The computer stopped itself to protect your data, waiting for you to plug in a repair tool and reset the ignition sequence. Let's say the engine runs perfectly, but you are locked out. Forgetting your main administrator password, the root password, feels exactly like dropping your only set of car keys down a storm drain. In the physical world, you might need to call a locksmith. In Linux, the machine allows you to be your own locksmith. By restarting in recovery mode, you bypass the login screen for a root shell. Because the system is read-only, you unlock the drive, then type password root to forge a brand new set of keys. You type your new password, restart the machine normally, and locks recognize your new key. You are instantly back in the driver's seat. This reveals a core philosophy of the system. If you have physical access to the hardware, you hold the ultimate authority. The computer assumes that if you can touch it, you own it, and it provides a reliable way back in. Have you ever seen a car weighed down by so much cargo that the bumper is practically scraping the pavement? It takes twice as much energy just to move forward. Your computer experiences the exact same strain when it hits a disk-full error. The system needs empty storage space to shuffle working files around. When the hard drive is stuffed to the brim, the whole machine slows to a crawl. To see how much weight we're carrying, the command df-h gives a summary of space left across the drive. Then, to find the specific boxes taking up the most room, we use du-sh to locate the heaviest folders. This massive weight usually comes from invisible clutter rather than your actual documents. Like overgrown logs, unemptied system trash, and temporary files act like sandbags left in the trunk, slowing everything down. The fix is pure housekeeping. You just delete the temporary files you no longer need, clear out the old records, or migrate massive datasets to an external storage drive. A computer grinding to a halt from a full disk can feel like a hardware failure, but it is entirely a space issue. Clear out the trunk and the engine immediately breathes easier. But what happens when the trunk is empty, the fuel is full, and the car is still struggling to accelerate? You click a folder and it takes 10 seconds to open. This visualizes a performance issue, usually related to your central processing unit, or CPU. It's like putting your car in neutral and flooring the gas pedal. If a single background program gets confused and demands all the computer's attention, your engine meter gets pegged in the red zone, leaving no power for your actual work. To see exactly what is pushing the engine so hard, mechanics use live diagnostic dashboards. In Linux, you open tools named top or htop. They provide a real-time monitor of your system's heartbeat. Looking at these troubleshooting steps, these tools rank every single active program by how much energy it is draining. You watch the list update live, instantly revealing exactly which specific application is acting like a runaway train. Every program gets a unique name tag, called a process ID. Shifting focus down to the next answer, you take that ID and issue a command called kill-9. This acts as a targeted emergency brake, forcing the unresponsive program to terminate immediately. The moment you apply that emergency brake, the heavy demand vanishes. The processor's workload drops dramatically, the cooling fans quiet down, and the system immediately returns to a smooth, responsive idle. A Linux operating system functions much like a well-tuned mechanical engine, with specific parts that perform specific jobs. Using these built-in tools turns a mysterious error into a solvable maintenance task.